Hello, welcome back. My name is Cal Inez, and welcome to Cal's Picker Company. And right now, we are discussing about the electric rating for MakerBot Mini Plus. Right now, we discussed the last video about how the electricity works on this printer, and that now there's a couple of people that did ask. Usually, the first one was a teacher, but now another one was asking the same thing about if there's any differences on the MakerBot Mini Plus 2 as well, or MakerBot Replicator, which is the other video, or which is the other image. I'm going to show you that. This guy right here, because we want to know like how it's compared to residential versus commercial electrical rating, and we'll discuss that at the end of the video. And right now we're discussing about these right here. So last time we were talking about is this right here. I was gonna tell you that we're gonna do this MakerBot Mini Plus as a sample, and it's very small for me to actually transport it. Then we have this meter right here, this kilowatt, the P3. So this was very helpful for me to actually like find the range, how far the power's at. Then after that one, we had to do some calculation, which I still not an electrical engineer. I am an industrial engineer, just that I'm not into the electrical components right now. So I'm still learning on that one. So still learning about the electrical components of like how it works and how it functions. So last time we were talking about is the one back here is the Replicator Plus Mini, and it's right here, this electrical rating, and it gives us the voltage, the amp, and the hertz of those three functions. It doesn't give us the other power, which is the watts, because that was the one that we have to do it by calculator, which is why you use the voltage and amperage. But again, this one's actually give us the ratings, how far it can go up from the lowest to highest. So that's our ratings, but we don't know how much power is being pulled in on this printer right away, because again, what this is off right now, and what power is not even connected to this printer. Sorry about that, my phone. Alright then. So anything right here. So oh yeah, and again, yeah, I have been taking this at home. I tried this one over here at the office. A few of them I kind of like didn't do it right, and after I had to take it back home, which is right here on this image. I had to take it back home to try it out on the outlet wall as is, and that way it'll see how well it can print out on the components. So that would go over here on this side right here. No, not a big difference, as you can see from the labeling. Not a big difference on the how it's being printed out. Still the same functions, still the same infills, the layers. It doesn't matter how it is, but with the power itself is a lot more different. So we're gonna show you guys that one how that works out. And after that, we're gonna go over here to the electrical system, how it all works. And yes, again, we had to go back to school. Right now, you're relearning again, back to school. We have to relearn it, everything else as it is to refresh our memory how these components works as an engineer, electrical engineer, fluid dynamics, thermodynamics, etc., etc. Okay, so as explained here on electrical, we don't know how to describe electricity, how it works. But right now, this is a analogy of how it actually compares this to the water valve and hose system to electricity. So on this one right here, we got is current, voltage, resistance, voltage pressure, which is the lower, and the wattage, which is the outside of the output of it. So as it shows right here that on the current and voltage, these two are the same thing. So the water itself is just mainly as is. So the water, there's nothing else happening right now. It's filled up in the tank. Don't worry about this right here. The this one, as long as it's inside a water tank, it will always be as is with the voltage. And we need to know how to actually put a output into it so that way it'll do something. For example, if you're trying to, I would say, I would say like a light bulb. If you try and plug into an outlet wall, that's your voltage. So we need to connect that voltage to see how much is being pulled into that one, the line. Now, next one is the voltage pressure, which is this guy right here. This one right here actually brings in the voltage as is with the for example, the electric line. If you plug in the outlet on, if you plug in the cable onto the wall outlet, that's as is. So now you're connecting the entire hose onto the water, and now you're connecting the plug onto the outlet wall. Now we have the resistance inside the components, which is the your plug. It will have resistance of the connection right away, and that once that connected to another output, which is a light bulb, that'll be a resistance to show you that how much is being flowed down or being flowed or being slowed down actually. So that way it'll like not cause a a lot of voltage going outward, because you don't want, if without the resistance, this will actually go out and it will be out of control. So we need to add the resistance to actually control that power and go from there. Once it has the resistance being controlled from the voltage from higher, it'll go down to low voltage, which is the lower pressure, and that will slow down the current of how much is being put out on the output. Now that once the output goes out, that'll be our wattage. That one is going to be the how much is being put onto the light bulb. So we have the outlet wall, the cable, resistance, whatever type of resistance it has, and the light bulb right here. So it'll power up the entire light as is. So now that compared to the um, output of this one right here, this one, it just gives us the ratings, how much it can handle. And that one, it'll tell us that it's going to be from 100 to 240 volts. We're going to focus on this guy right here. Right now, we don't have the amp and the hertz, so we don't know what that one is. But for the voltage itself, from residential and commercial building, it doesn't matter which voltage it can actually bring into. But on the electrical grid itself, that's coming in from the power plant, there's 600 volts coming in. So that's a high voltage right there. So that's very dangerous. So when that comes into your house or residential commercial buildings, it'll reach to a pole, but the pole has a transformer, which is a giant bucket container that slows down and also is a larger resistance to slow down that power, cutting down in half or a fraction of it to 300 volts. So commercial buildings, it'll have 300 volts or less than that, such as 120 to 240 volts. So that's our range, or it could be at the 300 range because it depends. So that will be discussed later on the end of the video. On the residential house, same concept, but a lot more lower because it depends on your power source. But on the what was it, the component on the outside, I just lost it. It was on the tip of my tongue. It's the the oh, I trying to get out of my, I'm trying to get out of my, it's a tip of my tongue. I'm trying to remember it. Damn, I always yell at me. Can't go outside. Turn on the. Anyways, it's a large box container that holds the entire electricity into that one. Not that you use the fuses on that one. Once you flip the switch, it'll turn to those electricity right there. So sorry about that. I'm trying to look for that term and the term for that one, the definition of that large box from the outside of the building. So so on that one too as well, same concept. It's gonna be 120 volts to 240 volts. Same ranges in between those. But again, it depends what your source is. So again, I will explain that along the way at the end. Okay, now then. I think we're done here. Yep, we are done. Okay, now let's go on to here right now. So right here, another analogy of the electricity. This is what it's talking about. So you have higher voltage going through here, and you have the current or resistance that we hold on to it, which is the whatever type of resistance you're looking for. It has to be powering outward, and it'll go to the lower voltage. As you can see, there's a lot of higher voltage going in, but we notice that we kind of like resistance to actually slow it down and bring out as much power as we can for the lower voltage. Right? So this is where I'm at right now. Yeah, LGE Smart Responders.com. If you want to look into that one as the more analogy of like electrical terms, how it's being used and how it's being discussed along. But again, this is the analogy how it's being told from the electrical component to a water hosing system to actually demonstrate how it works. So now let's get on to the fun part, is the Excel area. So now I'm going to bring up here. So right here, this is the one we were looking at on the MakerBot ULC on the power source, on the voltage, amp, and hertz. So from this side, it's going to be as is with all combination from the voltage, amp, and hertz. So our voltage as is there's no power connecting to it. It just gives us the rating from 100 to 240 volts. And then the hertz is going to be 50 to 60 hertz, and that's going to be used as is. Right now, this is the smallest amp. It's very, very small because of the 0.4 and 0.9. But I made another chart for that on this side to a larger scale. As you can see, it's from 0.00 to 1. from this one right here is going to be 0 to 250 power source of what's being used. So this is a demonstration to actually see how this works or works out right now. So this is what it looks like right now from the ratings, how it's being used as our lowest to highest ratings as it is. So it's our tolerance to stay at that area, and that's how much the power is being used on that 3D printer. Now, let's get on to the interesting part. Now, what we're going to is the home and office area. So as you can see, I've been doing this for 5 times on 2 different days. And the reason why for this one here, we have the first as the print, and the second one is the halfway point. So I'll explain that one. So the outlet wall from home is going to be 121 put to one. Actually, it's going to be ranges up to 121. Compared to the office here at the commercial building, it's going to be 122. But your hertz around there, it varies differently. It's like a steady fluctuation of going a little bit slightly down to 0.1 to 60. So it's like not that big of a difference from the hertz. It'll be 60, 60, 59.9 to 60 hertz. So again, I'm not sure how that electricity works on this. And also too as well, from the power, it kind of went down to about 1 point somewhere in that area of the voltage, where it went down to 121 to 122. But again, there's no big difference on that one. It's just a fluctuation of like being constant every now and then as it is, because again, nothing is being plugged into it. Now, the second one we did is a calibration cube, which is this guy right here. So we did some few areas. One is the calibration cube. We did Benchy, Marvin the keychain, and another calibration cube again. So there's 4 areas that's being used onto it. So the test cube and the calibration cube. Now then, once you're doing the calibration cube, the power itself from the start, when it's being doing the first beginning, the power, it actually went down to 1 voltage as it is, and an amperage saying it went down to like higher than I expected to be, and a wattage too as well. Then we can bring it along to calibration too as well, but the calibration doesn't make the difference too as well from the commercial building, where the power of the voltage, it doesn't matter. Same thing too as well, as you lost about 1 power onto that one. But on the amp is a lot more different, where it goes down to the 40 to 50s, and as it went down and going upward again. So there's like a big constant in between those 2 areas. But again, we're trying to figure out what's the difference between these 2 from the home and office, where the power can actually will be different. So, and after that, we go for the watts. Our wattage from the buildings in the commercial, it went down. Rather than this one right here, it didn't make it like a went down a little more. It just went out to the 55 to 68 and 49 to 60. Once you print out to 50%. And this is the same thing too as well. First beginning is going to be lower to 37 to 67 and 46 to 65 as steady ratio. Now, the 50% means that it's printing halfway, so the machine is still working itself. So it's like in the halfway direction. But again, it depends on the shape and how it's being printed out. So for example, we're comparing to the Benchy and the calibration cube. This is just a simple square, but with a few indents in the inside. While this one has a Benchy, the Benchy has a obscure design, and it varies differently from the inside too as well. And including inside too as well, the infill, it depends on how many you use the infill from the inside to work those machines, which is the motors, which I explained from the other video. It depends on how much work is being put into it with those machines, and each of those components have to print this component right here. But again, as it works all together, the power itself actually powers the entire thing, and this is the entire total amount of power is being used on that one printer. So now it's a little bit confusing on the numbers right here, which is, I know, is going to be a headache on your eyes, but we did another chart on the next one, which is the multimeter readings. As you can see, we can go above here, where we went up to onto this guy here. So this is the one at home. Now we can actually see the difference around the voltage. So our voltage, not that big of a difference. Like I said, it's not that big of a deal on its constant, and just varies differently on the like going ratio up and down, up to about 119 to about 121. So not a big difference. 3 volts went out. But again, the voltage is not that very important, because it's like a water tank it has to be used, but no activity has been used a lot. The one thing we have to focus on is the resistance, which is the ampere. So I'm gonna go over here on this side just a little more. I'm gonna bring oh wait, sorry, 100. There we go. voltage. Now we can go to the amps. Our amps is a little bit smaller, but we'll check that one on another chart. But our watt is the biggest one of all. Our wattage is a lot more fluctuating, as you can see from the 65s to 70s. It goes up onto that range, and then that goes to the other wattage from the different areas. So the outlet itself, there's nothing else happening. There's 0, 0, 0, nothing happened. But once you plug in the power, you can notice that the power is actually increased. It's being pulled in, so that's how much the wattage is being pulled onto that one, the power source. Hertz, not that big of a difference. It goes up to about 59 to 60, so we're not worried about that one. But again, the watts is the one thing we had to look into that one. So as you can see, it does fluctuate every now and then from the 50% to the other keychains from this home. As it is, it's being pulled out a lot more power. Now, compared to the office building, this one right here is a lot more different too as well. The voltage, not the big difference too as well, from 122 to 121, as it is from 120 to 119 to 121. But from this right here, the voltage, it's a little more bumped downward from the commercial building. Now that same thing from the other ones from the amps, not that big of a deal, but it does bump it a little more, which will be in our chart next one. The watts itself is a lot more different, where the watts actually fluctuate. This one was constant because of the test cube is actually a base itself. That was it. It's just printing out on its the simple base area. While this one right here for the Benchy, it does fluctuate because of the design, how it's being printed out. Same thing with the Marvin key as well. The Marvin key has a lot more obscure design that's being used a lot. So as you can see from the chart, these don't have to be used a lot. But the Marvin keychain is a smaller piece, so it doesn't use that much power. Rather the Benchy, it's a larger boat size. So let's go back to this picture right here. So from these two right here, small and big. This one's a larger one that it does print, and it does take a long time to print. It's a 45-minute print or maybe a 50-minute print out. While this one on the keychain, this guy takes about 30 to 28 minutes top because of the how well it got you print out. But after that, with the settings itself on the printer, it varies too as well, because you have to print out the speed, what's the infill, and what's the thickness of the layers. It depends on how much is being used. Again, from the previous video, it explained about how the power is powering up all the components. But right now, the electricity on itself, it's now powering the entire printer. So hopefully it does make sense. If not, don't worry, I'll explain that along the way. So as you can see, from the power from the watts, it does make a big difference from the commercial building and how it's being used. Now then, what about the amps? What's the big difference on the amps that we want to look into? So our next one is our amps. So this is the amps from the home and office, and this is what it looks like from the amps onto itself. So now it's kind of fluctuating how it is on the power source onto the lowest to highest. Oh yes, right. And I apologize too as well. The reason why there's two of them is because there's one that's low and one's high. So the lowest one, it'll go down, that it uses less power, while the highest is the highest one that it has to use up all the power. But it depends on where it's printing on this area. So for example, if it's the calibration test, which is the cube, it's just basically a simple square as it is, as it being printed out. It's just nothing else. It's just constant. But once it gets to the infill from the inside, it will bring it down a little bit, and that will actually increase the power itself. Marvin key, a lot more design, and it has to be printed out with a different calibration onto it because of the design. It will actually use some of the motors to actually go at certain points of the areas to actually focus on the design. Because again, from the Benchy and the cube is just a simple square. It's just gonna go straight, and a few areas right here. While the Benchy has a lot more design, it'll go circular. On this one, it has to have more power to focus on the X and Y direction to actually coordinate to make a circle. For example, if it's a square, it's just go straight. The motor will go straight to the Z, or it'll go straight to the X. It'll go straight to the Y. But on any design like a Benchy and the Marvin and this little guy right here, it will actually go around, or it can't do a straight line. So all the motors itself that goes on the X and Y, it'll have to make that circular in that coordination. So hopefully that makes sense. If not, don't worry, we'll learn that along the way with more printers. So there's a lot of more power consumption being used because, again, it depends on what type of print the parts that you'll be printing out right now. So same thing with the watts, same thing with the power, how it's being used a lot of where it's being used on a power source. But for the home and office is a lot more different. And again, I'll explain that along the way. So actually, I think this is almost the end right now. So um, this is a lot more different on the home and the office of how the power is being used a lot and how much being consumed too as well. It depends on the voltage and the watts, but the main ones could be the watts and the amps because those two are very most important because of the resistance, how much being used a lot, and how much power is being used on the printer to actually consume that power for that to make your part. Okay, now then, so how does this all relate it to the power source? Like, okay, how does it make sense on the printer that has a lot of components and still print out into one single component? So our first one is going to be the our electric skillet. So electric skillet is going to be the easiest one of all, and that one does consume a lot of power, and it's going to stay constant but turn off. So the electric skillet itself, back here, I think it was, oh yeah, right. Actually, you can still see the sign, the numbers. So electric skillet is a number consumer power source that's used a lot and it stays above frequent, actually it'll stay above. There's no going down like the printer as it is because it doesn't actually consume that much power. It's like fluctuating every now and then, like going up and down, up and down, up and down. As electric skillet, it'll constantly go up, up and up and stop because it has to warm down or cool down to cook your food. So on this one as it is with the same process but with a lot more of the numbers or how many times I have to use it. Number one is going to be as is with the electrical plug-in. The power source is not that big of a deal from 120 to 121 amp watts, nothing happened. But when you plug it in on the first start, there's no low voltage. It wants to consume that power. So this is the highest peak it'll bring up and it'll gradually go upward. So this is one is from the start of the beginning when you plug in the outlet onto the cord with the cord. This is the 117 volts. Your amp has doubled. So before the amps on this right here, it was way less because on the amps on this printers, it uses small motors and smaller components inside the printer. It doesn't use that much power as it is because again, it depends on like what you're printing. But for the amp for this electric skillet, it's the reason why it goes up to 10 is because it's bringing in that power to heat up your heating element. So if you want to cook your food has to go up to 400 Fahrenheit, but you need to increase your voltage to reach that Fahrenheit, which that one is a different concept for electrical engineering and also for the thermodynamics. That one discussed about the electrical and the heating system, how it's being used. So once it's going upward, it's always going to go up, 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 up. And then from the wattage, same thing, but it tripled the amount of power from the 0 to 1,257. So as you can see from the watts before, this one right here used to be 60, so that was like a little bit less power. But for the watts, it's 1,257 watts. And the hertz itself, as you can see from the hertz, not a big changes on the constant. Same thing with the heating. As it heats up, it's gradually keep going up, 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 up. And this one's still the same constant, or actually the number is now going upward from 116.6 to 116.8. Now that goes upward a little more, about 10.8 as it constantly going upward to bring in, it's drawing in more of the resistance in to heat up more and more and more as the heat increases every now and then. And the wattage too is itself from 157 to 159. But once it hit, I kind of hit that one too as well from the cooldown. I heard it click, and I rechecked to see what the readings actually say. It'll shut off everything. So it went back to number one to shut off everything else. Nothing happened. Except for the voltage is still constant inside of it, but nothing happened. So our wattage and our amps, nothing happens going on right now. Because right now it automatically cuts off the electricity inside the controller, whereas the thermal resistor, or actually the heating element and another component inside, it's a thermal I would say a device inside of it that once it reach up a highest heat, there's a little small copper inside of it. It'll bend backwards and it'll release the electricity, so that way it'll cut off right away. So it'll on the knob where you turn up from the lowest heat to the highest heat, it gives us the little copper to tell us that this is how much heat I want, and you have to like let go of it at a certain point that's being told right away. So, for example, 400 Fahrenheit. If it reaches up to 400 Fahrenheit, that little copper tongue will move up away from the electricity, and that will cut off right away. And after that, I had to double check everything else from the rewarm, and peak off, which is the highest one at the end of it. So once it means that the peak off means that I want to look at the end of it to see if it actually stops, and then I want to know the actual number. So this is the what it looks gave me from 116.3 to 121.2, 0 to 1076, and 1252 as constant. But again, it varies differently because these ones right here, it goes gradually back up again to rewarm itself from 1 and 2 to actually rewarm it back up. Now then, let's go check out the chart. So as it is, once we checked out the chart, as you can see from here as is, there's nothing right here, no voltage, nothing else. But once you plug it in, there's no low or zero, except for this one right here. There's two of them that went up, which is the heating. So it'll be the heating from here. So as you can see, these two have the 2 voltage right now. But your amps is always high, high, high. And the same thing with the watts. It's in between gradually fluctuating every now and then. So right here, as you can see from the voltage, no, watts, the watts actually increase its power up higher. So now it's kind of like gradually going up. So this is going off, plug in, it's going increasing, cool down, then rewarm again, go back up, increasing to the highest peak, and it's gonna start again, cool down, it's gonna stall over again. So it's like a fluctuating, it's kind of like fluctuating every now and then to heat up your element. So on this one right here, on the electrical component, on the electric skillet, this one draws out more power than any other electrical component right away. Like for example, the printer, because this one right here, it takes a larger heating source to heat up. Like for example, if you want to heat up your steak, heat up your pork chop, bacon, your breakfast, lunch, and dinner, whatever you're cooking, this one actually takes a lot of power to actually do the same process. It'll be the same thing from the printer itself, where you do the same wattage and the amps. It depends like how big it is. So now our last one, actually yeah. So it depends on the what sizes and what's your printing is. But now this is just a simple 1 hour. I think this I did about 2 hours. Yeah, because the calibration cube takes about 30 minutes. Marvin the key takes about 30 minutes, 25. Benji took about 45 to 50 minutes. And test cube about 30 to 25 minutes. So it's like about almost roughly 2 hours, 2.5 hours ish, give or take. Let's see, 30, it's about an hour, about 2 hours, so about maybe 2 hours, 2.215 might be around that area. So, or 2 hours, 15 minutes, 2 hours, 30 minutes, roughly that area. Including the skillet itself. The skillet, it does take longer because it has to heat up. It does take about an hour for this one to actually warm up. But the question is for your side is, okay, so I get the idea of the electricity. What's our time limit on our side now? And I can't believe I have to say this again, but we'll discuss at the end of the video again. So now the last one is gonna be the amp itself. Maybe we did this. Oh yeah, no, right here. So from the electric skillet as well, same concept. As could be going upward, as could go constant, bring it down, going upward again, constant itself, because again it has to bring up its the heating. Once it heats up and cools down, heats up and cools down. This one, it fluctuates every now and then because it has to be constant on the printing. How long does it take, and how will it do? Okay, now the last one. How long will it take for this one to actually do these printing? I tried to look for that one to actually compare these two right here from home and office. From home, I had to wait for a mail to come in with the electric bill to see the actual price, to see how much the price actually goes on to, if it goes toward the amps or the watts. The office, the other hand, I cannot say anything about that one. I did try to ask one of our front clerk, and she said that she's not in charge of that financial area. It's from the main campus that they're in charge of, and from their side, it's confidential, and they will not say, and they will not give me the data and the results of like how much is being used on the building itself that I'm at right now. So that's out of my hand, which I do respect their privacy too as well. If it was on my side too as well, I had to keep it secret too as well from the cost of it, of how much is being used and which powers that they want to like subtract into, either the watts or amps. But from the power sources from these two areas that I found out, they're used from the same company from Navajo Technical Utility Authority, NTUA, which they are in charge of the power and they bring in the power source. But what kind of power source do they use on their side of the factory? I don't know. That's the same thing too. Well, actually, from NTU campus, they do have a large solar panel, so that was one thing. But what's the other power source? I do not know. So that's the biggest one of all time too, as well. Of what type of power do they use and what type of grid system they actually use on that one. So, and what type of power source does it use on the power electrical grid system too, as well? That's the same thing too. I don't know what the power source is. So again, it depends what you have. Now the final one is, how do we measure from the power to the time, and how do we get the exact either the watts or amp? And that one too as well, which I do stress myself. I try to look for that one answer, is that it depends on what type of power source do you use. And that's the biggest one of all that really hits the spot. So because again, ugh, boy. So on the power source itself from home, from the picture that I showed you right here, as you can see, it does power the electricity right here, but you notice that I have more power from the background. There's more light. I use the light onto it. I have a charger to charge my phone. I have a refrigerator. I have TV. I have more chargers, which is at my mom and my brother. I have more lights again because they have separate rooms. It depends on like how much power is being used and being pulled into that home. Because again, I got all the measurement for the electrical component, which is the amps. Then we have is the voltage, watts, and the hertz. Yes, that's true. But those one, we don't know if that's the actual one. I can't just say like, oh, I'm gonna turn off everything else at home. I'm gonna focus on this printer. That's it. It doesn't work that way because there's more other components. If I unplug the refrigerator, depends on how long it's gonna last. My food will get rotten and my ice cream will melt. Then I need electricity too as well for the lights. Right now it's already 2 hours behind, so we're on daylight saving time. So if I try the printer but I can't see in the dark, that's the same thing too as well. You get the idea now. So it depends too as well, including the office as well. The office is gonna be a larger corporation. That depends. Are we a small corporation? Are we a large corporation? What type of power sources do you use? Are you using electricity, HVAC, which is the air conditioner, heaters? Are we using electricity for the kitchen? Are we using it for our heating water, which is for heating our sink, restroom, or actually not restroom, either the actually it is restroom, restroom, or could be used for like security, internet. There's a lot of different areas that it might interfere with this system. It is okay on the meter that it's already plugged in as is into the outlet wall, but we don't even know what our main fluctuation is. So, like I said, on the voltage and onto the outlet itself, it depends. Like on the one, it will say like, for example, the printer will say it's gonna be 100 to 240. That's good, but does that match over here too as well? Because we don't know what our lowest is. If it's like consume a little bit less power, which right now it doesn't consume that less. It's actually staying up to about 121, so it actually does reach up the highest peak. And it matches up the highest peak of the power of the printer that it needs to be used a lot. So, but the main biggest one that we want to focus is now the amp and the wattage. And we're going to do our calculator to actually do that one right now. So do the, which is called the electrical calculator, which is the voltage equals our watts divided by, I forget what was the amp. BW, I'll put A. Volts equals watts in amp. Or vice versa, could be either way, could be like volts equals amp divided by watts. Or if we're trying to look for another one too as well, like for example, we go back over here onto electrical component. We have the volt and the amperage. So what we're gonna do is vice versa. We're gonna use a calculator, or we're gonna use calculus now. And it's gonna be volts times our amp, and that'll give us our watts. Because again, we move from this guy right here. Let's go focus on this guy. So we have this right here. We want to equal this one. So we want to equal W. So now we're gonna go from divide by A to times A. Maybe this is the wrong one. It'll be like A times V, which is voltage, equals watts. So that'll give us our exact answer. And I had to follow that one because that's the only way to follow the correct calculus form or into a correct math format. Because if you move your A behind voltage, it's going to be A times V equals W. So it depends on which one. So this one, I can use this guy for our main source of power to see where's our watts at, which is right now we actually found our watts onto here because our meter actually tells us from all the power source from volts, watts, and amps. If we want to do it by calculator from this direction, that's fine by me. I can actually do it right now. Let's go over here. So if I was gonna do like, let's go for the highest one, be 121.6, 121.6 times. Then we're gonna look for our volts. Actually, whoops, wrong one. Be backwards. Back over here. It's gonna be times. The other one's gonna be our amps. Where's our amps? It's gonna be over here. Our highest ones from here is gonna be about 0, and our watts gonna be 0. So it matches up this right here, 0, 0. Or we can do is about 121.8. You can try that. And yeah, you guys will be learning a lot from here. So. And this is a refresh for you guys if you're like electrical engineers or as an electrical student, you guys are good to go right here. And it's going to times 0.59, 0.59, and we're going to try equal, so that way it'll give us the information. Enter, and that should give us about 71.862. So from here, as you can see from here, it doesn't give us the exact number. So from the meter itself, it does say 68. Now the reason why it says 68 on the meter, because it's trying its best to actually fluctuate on top. But this is the exact number of 71.86, and I will do the same thing from the rest of these guys to actually get the exact watts. Including Benchy itself, I can actually do this from here to 0.6. It'll give me the watts itself. Hopefully it does equals up to 70, which I'll do that right now. But again, it depends on the meter itself while I'm talking right now. So from the meter itself, it did tell me that it is close as what you're looking for, but not the exact answer as you're trying to look for on the result. So you have to do the math on your own side. 9. You have to do your math on your own side. Yay, 70. So almost like 70.12. So it is like roughly around there, that 70. And let's go check out our amperage too as well. So we have is about 0.9 to 0.45 and 240, which we're now in the between the range from this guy right here from 120 to about 0.6. Yeah, 0.6 amps. So right now this is the machine is okay from the fluctuations that stays between that rating of the printer itself. So it is like okay, but we need to know like what's our, again, like back to your question, where can we find the exact amount of amp and watt? So that will be the next one next time on our video for like where can we find the exact money or the pricing. So I'm gonna go back home to either wait for electricity bill to come in and then see what's the exact money is on that one. Use that price to calculate for either the amp, voltage, and watt or the consume that one, and see how long does it take. This one takes about 2.5 hours. So hopefully we'll see how that goes from here. 0.5 again, because I didn't do my time correctly yet. I didn't do that right, so that was my fault on my side of misinformation. But again, I could do one here at the office to go compare. No, wait, no, I don't have the office. Well, let's go do the one at the home. But the office one, we don't know what's going on with that. So that's the biggest one of all. Okay. All right, then. Hopefully that does explain electricity on your side. And hopefully it does answer the question for your how much electricity has to pull into your side. Because again, it depends on your side on how much you're consuming. Are you consuming the TV, lights, your water heater, It depends because it depends on your electric bill, and we have to see that one to see if it does show how long does it use. And on top of the two as well, you're using your power source every day, 24/7. From the commercial building, it'll be on all the time because of the heating system and the water heater itself. So it uses that one 24/7. So I don't know how much the exact time it does use that one. Compared to the residential home, it can be electricity for like the refrigerator. That's 24/7, and your charging your phone devices, it can be used out for 24/7, and could be used toward your direct or your TVs too as well, which is your little um the main component of your device. So it depends what your electric bill has, and you got to use that in price of the exact final cost onto these sources right here. So hopefully it does help you out right now, and that I hope you enjoyed this video for the electrical ratings. And please give it a like and share. And next time we'll compare it to the pricings, its final result to see how it come out. Okay. All right, then give me a like, subscribe, follow me on these directions. And then next time we'll try the MakerBot replicator, see how much power that one brings out, and go from there. All right, then. Goodbye.